Well, hello everybody. So actually no one has shown up yet, so I'm um, just going to record this anyway so that you guys have this lesson. So this week we learn about three different techniques for solving quadratic equations. We got solving by factoring, solving by taking square roots, and then the quadratic formula. So I'm focusing this one on the quadratic formula, and I'm going to also compare it to the other two so that you can see where it's used, advantages, disadvantages. So first off, we get the quadratic formula by taking a quadratic equation, which is in standard form, which is ax squared plus bx plus c equals 0. And then you go through what's called completing the square. We don't really cover completing the square in this class. I believe it's briefly touched on, but it's not something that you use very often. The textbook actually goes through the whole process of where that comes from to get the equation and how you get there. And so I don't expect you to memorize how to get to the equation. I'd prefer that you just memorize the equation. But I do want you to know that a lot of formulas that we use in math come from basically doing procedures that we learn, but doing them with literal equations, which means only variables or very few numbers. So any other formulas that you may know about come from this process, as working with everything in terms of definitions, not actually using any numbers, and then you do that to create a formula, essentially. So that's sort of how the quadratic formula came about. That's how other formulas came about. Sometimes they require a lot more work, like the cubic formula we don't even teach because it's just insane. But it's basically sort of the same process. You end up having to do the quadratic formula multiple times, and it just you get square roots inside square roots. It's just gross. So just memorize or have written down what the quadratic formula is, and just understand where it came from, and just the process that we come to get formulas. So I'm going to it's a formula. All we're doing is plugging in numbers. So it's just a matter of doing lots of examples. You are going to need a calculator for most of this. You're going to want a calculator that can take square roots. I mean, a simple scientific calculator can do that. And if you're trying to save yourself from mistakes, if you have a calculator that can enter all this in one step, that's great. But not every calculator can do that, and you have to make sure that you enter it in exactly right with parentheses all in the right place and everything like that. So it is sort of a complicated formula, and it's a lot of calculations. And most of the time what happens is somebody does a multiplication wrong or an addition wrong, and it's a arithmetic error, not an error in the formula itself. Or maybe you accidentally put the wrong number in the wrong place. That's another common error. So it's because of that, I actually don't use the quadratic formula until I have to, unless there's no other method, because it's so prone to mistakes. So with that being said, this first problem here, we're going to solve this equation by factoring and then using the quadratic formula to kind of show you each method side by side. This is one where I would do it by factoring, not the quadratic formula, because it's actually quicker, fewer mistakes. And so there's a time and a place for everything. And in this case, if you can factor, I recommend doing that first. So we will do the factoring first, and I will do that on the right side because I have the quadratic formula on the left. So when you're factoring x squared plus 7x minus 12, you're looking for, you're going to put it in a specific form where you have two sets of parentheses. So that left is being factored. You still have your equal to 0. The first spots, so this spot here, this spot there, those need to multiply to get to your first term, your squared term. So you get x squared. So that's going to be x times x gets you x squared. Then the last numbers need to multiply to the constant. So I'm looking for two numbers that multiply to negative 12. Actually, what I should have done is made this a plus 12 now that I'm looking at it, because otherwise it's not going to work. So we'll make this multiply to a plus 12. Must have been a typo on my part, writing the wrong symbol there. So you want two numbers that multiply to a positive 12. And so there's lots of combinations: 1 times 12, 2 times 6, and 3 times 4. So you have multiple choices, and you want them to add to 7, the middle term. So 3 times 4 is the only one that adds to 7. So it doesn't matter which location I put them in here. I just put them in their proper locations. And then in order to multiply to a positive and add to a positive, they both need to be positive numbers. So this factors to x plus 3 times x plus 4. So when we solve by factoring, once you factor, then you set each factor equal to 0. So we get 2 equations, x plus 3 equals 0 and x plus 4 equals 0. So we get 2 equations, and we're going to have 2 solutions. So a quadratic equation has x squared. That degree, or the highest exponent, tells us how many solutions we're going to have. So because the highest exponent is 2, we're going to get 2 solutions. This is different from linear, where there was no exponent, or basically an exponent of 1, so you get 1 solution. So we factor, and now we have 2 linear equations. So one of the things that I talk about, I might have talked about in another video, is that as we go further into the algebra, you take more complicated equations, and then you're breaking them down into simpler ones. So we took something that's quadratic, and now we have broken it down into linear. So we took something, we did some steps, and now we broke it down into something that we learned in like week 1. And you're always going back to the basics. It's just a matter of how do we break these down into the basics. So factoring is one of those ways that we take a quadratic and break it down into linear equations instead. So I've got 2 linear equations here, and then I'm just solving for x. So the first equation, I need to subtract 3 from both sides, which gives me x equals -3. And then the second equation, I'm going to subtract 4 from both sides, which gives me x equals -4. And it's done. So we've just solved that by factoring. So when something says solve, you're trying to find x. When it's a quadratic, you need to decide which method. If they tell you a method, then that's what you do. Otherwise, you have to pick based off of what looks like the easiest in your knowledge. I always recommend trying to do factoring whenever possible, especially because we're going to be factoring so much. It will help you get more practice at factoring and get quicker at it. So solving by factoring means first factoring, and you set each factor equal to 0, which is the 0 factor property. It's a rule that says we're allowed to do that. And then you solve, and then you have your 2 values for x. So now let's use the quadratic formula for this. And so I'm going to do this one in yellow. So I've got the quadratic formula on the left here. And you can see in the quadratic formula, let me make my U actually look like a U. We've got A's, B's, and C's on the right. So these correspond to standard form of a quadratic. So the number in front of the x squared is A. What's in front of the x is B. And then the last number is C. So in this case, we have A equals 1 because there's not a number. B is equal to 7. And then C is equal to 12. Labeling these A's, B's, and C's should be familiar because when you factor using the AC method, you need to also figure out, okay, what is A and C? And you're using the same labels. So once you have your variables, you know what A is, you know what B is, and what is C, and you plug them into your formula. So we've got x equals -b, so B is 7, so that's going to be -7. Plus or minus, so that plus and then a minus sign, that's the plus or minus symbol. That just basically means we're going to get a positive version and a negative version. That's how we get 2 solutions. I do talk about that in my radical video, talking about radicals. And when you take a square root with variables, you get a positive and a negative answer. Because squaring a negative leads to the same answer as squaring a positive, so that's why there's 2 possibilities. So plus or minus just means that at some point, we're using it as a shortcut so we don't have to write 2 equations, but at some point we will have to write 2 equations. So we've got that plus or minus symbol, and then we have our square root. And inside the square root, we have b squared, so that's going to be 7 squared Then we have minus 4ac. So that's 4 times a, which is 1, and then times c, which is 12. You need to make sure that your square root symbol goes over everything there. This is the same thing if you're using Alex. You want to make sure that everything that's inside the square root is actually inside the square root. You need to pay attention to where your line ends. Make sure you don't have things under the line that aren't supposed to be, or things outside the line that are supposed to be in the line. So you have to be very particular about that, because otherwise, basically that length of the line tells us what's in the square root. So it's really important. And then in the denominator, we have 2a. So it's 2 times a, which is 1. So 2 times 1. So now we've got this formula with our numbers plugged in, and we want to simplify the right side, so we have to follow the order of operations. And so for the order of operations here, we have PEMDAS, P, which is parentheses, but it's basically just grouping symbols. And what this means is we want to do things that are grouped together first. And things that are grouped together right now are the things inside the square root. That's considered one way to group things. Or things on separate sides of a fraction, so like the 2 times 1. So I'm going to kind of do these at the same time to save space and time. So I'm going to try to simplify inside the square root first, and I'm also going to multiply the denominator. So now to simplify inside the square root, we're still following the order of operations, and so the next step would be to the exponent inside there. So my next step here, I'm going to do my exponent, and then I'm going to multiply in the denominator. So I'm going to do those in the same step. So I have x equals -7 plus or minus, and then I have my long square root symbol. So I have 7 squared, which is 49. Now, because the minus 4 times 1 times 12 is a separate term, I really could do those at the same time. And if you really want to save space, I recommend that you do that, because this is a very lengthy process if you don't. So I'm going to multiply 4 times 1 times 12. So that gives me 48. So this is going to be minus 48. That minus sign in there. So I've simplified, I did my exponent, and then I did my multiplication because they're in separate terms. I'm allowed to do that. And then I'm also going to do 2 times 1, which leaves me 2 in the denominator. So now I still need to simplify inside the square root. So I need to do that subtraction, 49 minus 48. So I need to rewrite my next step, x equals -7 plus or minus. And then this is still inside the square root. 49 minus 48 is 1. And then this is over 2. So now I have -7 plus or minus the square root of 1 over 2. To simplify this further, I need to actually take the square root of 1. So you can do that on your calculator. Square root of 1 is something you just want to know is equal to 1. So now I need to rewrite that by taking the square root of 1, which results in 1. So I actually have to go to another slide here because I don't have enough room. So I've got x equals -7 plus or minus 1 over 2. Now I have this -7 plus or minus 1. We can't combine things with the plus or minus symbol in there. I can't add those. This is where I have to create 2 equations. So this gets split up into 2 equations. One with the positive symbol, -7 plus 1 over 2. And then one with the negative symbol, -7 minus 1 over 2. Now we've got 2 equations, which is going to give us our 2 solutions. And so now we need to continue with the order of operations by using our addition and subtraction. So x equals -7 plus 1 is -6. So I have -6 over 2. X equals -7 minus 1 is -8 over 2. And then we want to simplify those fractions, which in this case we can divide those. We get x equals -3. And x equals -4. As you see, these are the same answers that we got by factoring. But it took twice as long. It took some more complicated math, took a lot more space. You get the same answer, but it's longer. So in this is why I recommend factoring whenever possible, because factoring is quicker. And if you're taking a quiz, that's what you, especially a timed quiz, you don't want to do the slow method every time because you're going to run out of time. You want to, one of the things about teaching you different methods is knowing what method to use when, because that's part of the problem solving thing, is knowing which is the best method for this situation. That's a skill used in life for anything, even if it's not math. So that's one of the things that you kind of learn by learning methods, and then having a timed exam is knowing which is the best method, the most efficient method, the quickest method. In this case, that would be factoring. So you want to make sure you're good at all of these methods so that you can choose the best one. You don't want to do just one method. For example, not everything can be factored. So if you're saying I'm only going to do things by factoring, you're going to run into some issues where it can't factor. In those cases, that's when we use the quadratic formula. So I think of the quadratic formula as like a last step. First, try all other steps first. If none of those work, then do the quadratic formula. That's how I look at it, because the quadratic formula will always work, but it's so long that it's certainly not the most efficient. So, second example, this one we're going to solve by taking square roots and then with the quadratic formula. So again, you can see how you can use it in different situations. So we've got 121x squared plus 4 equals 0. So I'm going to do square roots on the right. And so in order to solve by taking square roots, you do this when you don't have that middle term. So in this case, our middle term is gone. We don't have an x. So you want to get the x squared by itself. So I'm going to start by subtracting 4 from both sides. This gives me 121x squared equals -4. And then you want to divide both sides by 121. Oops. X squared equals -4 over 121. And now taking square roots means you take the square root of both sides. So take the square root of x squared, and then I'm going to end up with a plus or minus. And then because I'm taking the square root of the negative, I'm going to have a complex number. So I'm going to get x equals plus or minus. Now I usually just put my complex number there immediately, knowing that the square root of a negative is going to give me an I. And then we want to take the square root of 4 and the square root of 121. So that's using our rules of square roots, where if you have a fraction, you can do the top and the bottom separately. So the square root of 4 is 2. Square root of 121 is 11. So if I were to write this as two answers, we could write this as 2 over 11i because the positive, or -2 over 11i. If you're asked to write it as a set, what you'd be doing is putting curly braces around it. So if it says to give the answer or the solution set, you need to put it in curly braces to indicate that it's a set. So this is not something you can factor. If you have anything that ends up with complex numbers, that means you couldn't factor. Doing it by square roots isn't bad. It's not hard. Probably the most difficult part is the complex number part and the fraction, but it's not difficult. Like, it's just, okay, these are things that you have to take care of and worry about. So now let's compare this again to doing it with the quadratic formula. So again, we need to identify A, B, and C. So A is the number in front of the squared term, so that's going to be 121. B is the middle term, the x term. Because that term doesn't exist, it's 0. And then C is the constant, so that's going to be 4. So now I'm going to plug these into my formula. So I have x equals -b. So that would be -0, which is just 0, but I'll actually literally write it down so we don't get too confused. Then we have our plus or minus. Long square root symbol. We're going to have b squared, so that's 0 squared minus 4 times A, which is 121, times C, which is also 4. Make sure I continue my line, fraction line. I have to make sure that's covering everything correctly. And then in the denominator, 2 times A, so that's 2 times 121. We're going to get some pretty big numbers here. So next step, negative 0 is 0. So I don't need to write that at all. I just have the plus or minus symbol. 0 squared is 0. I can't ignore that because I still have some, I guess I could just ignore that, but I'm going to write the subtraction there just so it's not too confusing. And then I need to do 4 times 121 times 4. So that's definitely calculator. And that's 1936. And then in the denominator, 2 times 121, so that gives me 242. So you can see that the quadratic formula is creating larger numbers that you have to deal with. So that's one caveat or one reason why I avoid it, unless it's the only method, because it does create these bigger numbers. So 0 minus a negative is still 0, so I'm going to just erase it. So we still have a square root of a negative, which is going to give us an I. So what I'm going to do is just write the I, and then this is the square root of 1936 for 242. So I need to keep going. I have, actually, I didn't give myself enough room here, so I need to actually add another slide, a blank slide. Give me a moment. Okay. All right. So I need to now take the square root of 1936. And you always want to see if it comes out to a whole number. In this case, it does. But if it doesn't, then you need to use our techniques for simplifying radicals, where you're going to still have the square root in your answer. So I have x equals plus or minus, and the square root of 1936 comes out to 44. So that's going to be 44i over 242. So we have this 44 over 242 that we need to reduce. So this is a fraction that we need to reduce. I believe I can divide them both by 4. No. So let me divide it by 2. So I'm going to just indicate that with green. I know these are even numbers. So to reduce it, I'm going to divide them both by 2. And you need to make sure if you're going to write that, you need to do it on the top and the bottom. And then I'm going to just go to the right, because whenever I reduce, I do it on the right. And the plus or minus doesn't have to be in the fraction. It could be outside the fraction. And the I, because it's on top, can also be outside. So anything on the top of a fraction can also be put in front of the fraction. You can't do that in the denominator. It's only if it's in the top in the numerator. So 44 divided by 2 is 22. 242 divided by 2 is 121. And I can divide 11 out of both of those. So I'm going to reduce these by 11. This will give me plus or minus I, and then 2. 2 over 11. So we basically are getting the same answer we did before, plus or minus I, 2 over 11. And it took not that many more steps. It was only a little bit more steps. But we did have to deal with larger numbers. So in this case, it sort of depends. I still would have done the square root, because most of the time the square root solving is easier, not as many steps. If we didn't have any zeros, we could have gotten nastier numbers. But it's almost the same amount of work in this case. But I still think that the square root property is cleaner, easier to follow, especially with our rules of solving. You get the same answer either way. Okay, so now I've got several different ones that we're going to solve using the quadratic formula. Again, the quadratic formula can be used in every case, but it is a longer process. It's good when you have anything that can't be factored, because then you tend to either get imaginary numbers or square roots, and so the quadratic formula is how you get those things. So we have here z squared equals negative z minus 19. In order to solve, I have to get everything on the same side. So I need to add 8z and add 19 to both sides. Or I could subtract z squared from both sides and work with negatives. The nice thing about the quadratic formula is that it doesn't matter. Generally, when we have quadratic equations, we want to have our squared term be positive. But with the quadratic formula, it does not matter. So I can rewrite this as 0 equals negative z squared minus 8z minus 19, and work entirely with negative numbers. So a is going to be -1, b is -8, and c is -19. So what I recommend doing is you always write down the quadratic formula just to help you remember it. So it's x equals -b plus or minus the square root b squared minus 4ac all over 2a. If you write it every single time you use it, that helps you memorize the formula. So I'm going to start plugging in my numbers. So we have -b. Now b is already a negative, so when I plug it in, I need to make sure I put parentheses around there just to keep that negative, because b is a negative. So that's a negative and then a -8. So those will become a positive there. And I have my square root. And again, if I'm plugging in any negatives, I'm going to have parentheses around it. So b squared is squaring -8. So I have to square the entire thing. -4 times a is -1. And c, which is -19. And then if this is what I put into Alex, I would get it wrong because I need to have the entire thing over that square root. So I have to make sure that they're all inside there. And I have to make sure the whole thing is over my fraction. If you don't have your fraction covering everything that it needs to, again, that would be incorrect. And then I have 2 times -1. So there's going to be a lot of calculations here. And again, I'm going to just try to simplify it whenever possible. And when I'm trying to conserve space with the quadratic formula, what I will tend to do is get kind of messy, and I'll move from left to right and then go under, then move left to right. And that's fine because we're not doing anything on the left side. All we're doing is simplifying the right side. So if you're only simplifying one side, you are allowed to go horizontally. In math, if we're simplifying both sides or we start doing things to both sides, that's when you have to go vertically. But we're not, and that would be if you were like solving where you have to add or subtract to both sides. Here we are now evaluating. So evaluating means you're plugging in numbers and then doing the order of operations, and that's something that you can do horizontally. So that's what I'm going to do to sort of conserve space here. So looking at what we have, I have a -8. So those two negatives cancel. So I have a +8 and then my plus or minus. Now I'm going to have my long square root. So I need to square -8. Squaring a negative gives a positive. So that's going to be a +64. And then I have a -4 times a -1 times a -19. So you can just leave that subtraction there and then do 4 times -1 times -19. And that gives you a 76. So we're going to have 64 minus 76. And now my square root's too long, so now I'm going to fix that. And I can see already I'm going to get imaginary numbers here because I'm going to get a negative under the square root. And then I have 2 times -1, so that's going to be -2 in the denominator. So now I'm going to go to the next step. So I'm going to start rewriting it again. And I'm going to simplify under to the square root. So 8 plus or minus, and then I need to do 64 minus 76. That gives me the square root of negative 12. And then I have my negative 2. So that negative inside the square root I need to pull out because it's going to give me an imaginary number. So I'm going to get 8 plus or minus. And I always put the I in front so that it doesn't look like it's inside the square root. I know that most textbooks will put it at the end, but then especially if you're putting it into ALEKS, you might accidentally put it in the square root when it's supposed to be outside. So I put it in front to kind of just make it clear it's not inside that square root. So now we have the square root of 12, which if you put that in your calculator gives you a decimal. So that means you need to simplify that square root. So square root of 12, I can split that up in my I as the square root of 4 times the square root of 3. And I chose 4 because I know I can take the square root of 4. That's going to give me a whole number. So that's what I'm going to do. I'm going to take the square root of 4. This gives me 8 plus or minus 2i. That 2 is coming from the square root of 4. And then I have my square root of 3. And then over a negative 2. We have an I, which means we would not have been able to factor, and we have a square root we would not have been able to factor. Using the quadratic formula is the only way to solve a problem like this because it's coming up with things that are not whole numbers. So this is the only method to solve something like this. So now we have to simplify it, and so now I'm going to split it up into two separate equations, one with the positive and then one with the negative for the plus or minus. So I have x equals, I'm going to have 8 plus 2i times the square root of 3 all over negative 2. And actually, you know what? I think before I'm going to do that, I'm going to do another trick. So when you have a plus or minus on top of a fraction like this, we actually like to split the fraction up so that you have like your first part over the fraction and then your second part over the fraction. So let's do that because that will actually make things easier here. So I'm going to have x equals, and I'm going to have 8 over the negative 2, then have my plus or minus symbol, and then 2, let's see, the square root of 3, and then I, if you're going to write it like we should, like what the book does and everything, and then over that negative 2. So if you split it up like this so that you have that plus or minus in the middle and they both have the same denominator, it's a lot easier to simplify because you can see the 8 over negative 2, that comes to negative 4, plus or minus. And then the 2 divided by negative 2, that is a negative 1. So we'd get a negative 1 and then our square root of 3i. Now, mathematically, what we generally do if we have a plus or minus with a negative is we just switch the order, and then this becomes what is called a minus plus symbol. But effectively, it means the same thing because we still have two answers, a positive version and a negative version. So if we were to write the solution set, we'd have negative 4 minus the square root of 3i, and I'm making sure that I is not inside the square root of 3, or negative 4 plus the square root of 3i. If I had left the plus or minus with the negative 1 in front, you would get the same answer. You would have plus a negative 3, which is minus negative, or not negative 3, square root of 3, or you'd have minus a negative square root of 3, which is plus square root of 3. So it comes out to the same answer. So if you see a negative and then a plus or minus, that just basically means to take the opposite of the plus or minus, which then is a minus plus symbol, and then you get these two answers. It looks gross, but this is the only way to solve a problem like this. And way back when, before they created imaginary numbers, as you guys are learning about, they wouldn't have been able to solve a problem like this because they didn't have imaginary numbers, And even before then, they didn't have radicals. They didn't have those kind of numbers, irrational numbers, so they wouldn't have been able to solve this at all. So this is something that later mathematicians came up with a method so we could actually find solutions like this. So, next one. Now I'm switching variables. And this is important because the quadratic formula looks the same, but everywhere you see x, you then have to write your other variable. And you want to be careful about that in Alex, because if you put the wrong letter, it's going to mark it wrong, or it won't let you type that letter if it's the wrong letter. So keep an eye out for that. So I have m times n plus 10 equals negative 34. So in order to solve any quadratic equation, regardless of whether we use the quadratic formula or not, you need to put it in standard form. And this is not in standard form. If it was factored in equal to 0, we could solve, but it's not equal to 0. So what we need to do is distribute, then put everything on one side, and then we start solving. So I'm going to distribute. That will be m squared plus 10m equals negative 34. And then I need to add the 34 to both sides. So I get m squared plus 10m plus 34 equals 0. Now this is in a form that we can solve. And this can't be factored because I believe it's 2 times 17 gives you 34, but that will not get you 10 in any way. So that we have to use the quadratic formula here in order to solve this. So I'm going to start by identifying a is equal to 1 because the number in front of the square term is 1. B is equal to 10. C is equal to 34. And so again, writing the quadratic formula, I'm being careful to write m instead of x because that m is our letter. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. I almost plugged in the number. Not there yet. So I need to plug in these numbers. M equals negative b, so it's negative 10 plus or minus square root b squared, so that's 10 squared minus 4 times 1 times 34. So a times c, and I need to make sure I draw my line all the way. Entire fraction, and then 2 times 1. So doing the quadratic formula is a very tedious process. It does get old doing it on multiple problems, which is why I suggest quicker methods whenever possible. So we got to work through all of this math, order of operations, but you notice we're basically doing the same steps every time. So it does sort of get routine. So we have our negative 10 plus or minus. So I need to square the 10, which is 100, and my minus sign, and then 4 times 1 times 34, which is 136. So once again, we're going to get imaginary numbers here. And then in the denominator, 2 times 1 is 2. So now I need to simplify inside the square root. And again, I need to make sure I'm writing m. M equals negative 10 plus or minus square root. Now 100 minus 136 is going to give me a negative 36 over 2. I'm going to pull out the negative to get an imaginary number. So that's going to be negative 10 plus or minus I times the square root of 36 over 2. Now the square root of 36 does come to whole numbers, so that's going to be nice. So that is negative 10 plus or minus 6i over 2. I'm going to do the same thing that I did on the previous problem and split this up. So it's going to be negative 10 over 2 plus or minus 6 over 2i. So that will make it a lot easier to simplify these. And then I have m equals negative 10 divided by 2 is negative 5, plus or minus 6 divided by 2 is 3. and then the I. So our final answers, it's very tedious, -5 plus 3i, and then -5 minus 3i. I'm going through the arithmetic pretty quickly, and that's because, well, this class is focusing on algebra, not the arithmetic. Arithmetic is like the addition, the multiplication, that kind of stuff. And you want to be able to do that stuff fast, because if you're getting caught up on the arithmetic, then you're going to get slowed down on the algebra stuff. So that's why it's so important to know your multiplication tables really well, or your division, that kind of stuff, so you can do a lot of it mentally, because it does take time to type it into a calculator. And often it's faster to just know the answer immediately than to type it in, and it can save you time. Okay, so lots of examples here. I'm actually going to skip this next one because I want to show you ones with decimals and fractions, because I know those are going to cause issues. So this one we have decimals. Now you can do a quadratic formula with decimals that works. There's no reason that it doesn't work. If you want, you can turn them into whole numbers, but as long as you use a calculator, it doesn't matter. So I'm going to just work with the decimals because I have a calculator. I can. So I'm going to start by, again, I have to get everything on the same side. And because it doesn't matter the signs, I'm going to just subtract the 0.09 n squared from both sides. So that would give me a negative 0.09 n squared plus 0.42 n minus 0.49 equals 0. So just keep in mind your signs. Don't lose any decimal points when you're doing something with decimals like this. So our quadratic formula, we have the letter n, so now it's going to be n equals negative b plus or minus square root of b squared minus 4ac over 2a. So a is negative 0.09, b is 0.42, c is negative 0.49. Calculator required here. N equals negative, and then I'm plugging in my numbers. So b is actually positive. I don't need those parentheses. Negative 0.42 plus or minus. I'm going to just skip writing that 0 before the decimal point because it's assumed that it's there. So I'm going to just use 0.42 squared for that b squared minus 4 times a. So that's a negative 0.09 times c, which is a negative 0.49. And then the denominator 2 times negative 0.09. So because of all these decimal points, this is going to take a lot more work. So I'm going to make sure that I have enough slide space for this. I think I'm going to need 2 slides. So I'm going to just add in another blank slide there. Okay, calculator for sure here. N equals negative 0.42 plus or minus. And I'm making big decimal points so they don't get lost. Okay, so I have to square 0.42. So this is giving me 0.1764. I have my minus sign. I'm going to do 4 times negative 0.09 times negative 0.49, 0.1764. Okay, do you see how the 0.1764 minus 0.1764, that's going to give us 0, and that's actually going to come out really nicely for us. But that will also mean that we have only one number as our solution, so it's a special case. The denominator 2 times negative 0.09 is negative 0.18. So I'm going to go to the right here. We have negative 0.42, and we're going to get plus or minus the square root of 0. And the square root of 0 is just 0. So basically, that disappears. And then if you have plus or minus 0, you don't really have that plus or minus. So we just have negative 0.2 divided by negative 0.18. Because the square root part just disappeared completely. So you see we get only one answer here. So negative 0.42 divided by negative 0.18. And so when you're working with decimals like this, and I divided it, I actually got 2.33 repeating. So generally, if your given problem is in decimals, you can write your answer in decimal. But sometimes something like this, the 0.33 repeating, means it's going to be a third, which means I can write this as a fraction. So if I was to write this as a fraction, so one, if you have a calculator that converted decimal to fraction, I would totally do that because that saves you work. My calculator does do that, but I'm going to show you how you can do it otherwise. So basically, you can move your decimal points on the top and the bottom of the fraction. So if I move my decimal point to the right by 2 places, I also need to do it on the bottom by 2 places. So you have to do it on the top and the bottom the same. So that would be n equals, that would give me negative 42 over negative 18 if you do that. So the negative and negative divided by negative is a positive, so those cancel out. So it's just 42 over 18, and then we want to reduce our fractions. I can divide those by 3. Actually, I can divide by 6. 6 goes into 42. So that would be even bigger, so we'll do that. So 42 divided by 6 is 7. 18 divided by 6 is 3. So this would give us a single answer of 7/3, which is the same thing as 2.33 repeating. So the form your answer here, if you were doing this for something on paper, it wouldn't matter. But in ALEKS, you do want to check to see if they provide you with a fraction button. That means they want the answer as a fraction. So if that's one of your options, that's how you need to write your answer. If it's not provided, or if they tell you where to round, then you can leave it as a decimal. It looks like I didn't actually need that second slide. Okay, last one, and I'm not going to solve the whole thing here. I'm just going to show you how you want to rewrite this so that it's easier to solve, because doing the quadratic formula with fractions inside the square roots and all that stuff is very hard. It's just, it looks gross, you don't want to do it. So when you have something like this, what you want to do is first eliminate fractions by multiplying both sides by the common denominator. So all our denominators here are 2, 7, and 14. So the common denominator is going to be 14. So you're going to multiply both sides by 14. And when you do that, that's 14 over 1. So when you're multiplying with the fractions, the top is going to be multiplied by 14. So this is going to give us 14 over 2x squared minus 28 over 7. And then I don't know what 5 times 14 is. My calculator says that's 70 over 14x. And then you're going to divide all of these, because by multiplying by the common denominator, you're going to get whole numbers here. So 14 divided by 2 is 7, so we're going to have 7x squared. 28 divided by 7 is 4, so that's minus 4. 70 divided by 14 gives me 5, so that's going to be 5x. So now we have whole numbers, and it's a lot easier to work with the quadratic formula here. I don't work with the quadratic formula fractions. It's just gross, so just don't do it. So make it something with whole numbers. So we're going to want to subtract 5x from both sides. And this will give us 7x squared minus 5x, then the minus 4 equals 0. So now it's in standard form. So your quadratic formula would have a equals 7, b equals -5, and c equals -4. And then you would solve using the quadratic equation from here. So I'm not going to do that because this is a long video, but I did want to show you what you can do to take some of the fractions so that it's a lot easier to solve. And you want to get rid of those fractions so that you don't have to deal with them inside your quadratic formula. All right, so I know this is a lot. Hopefully, since no one actually came live, you guys sit through the entire hour or so here. If not, at least maybe you skip ahead or kind of look at different parts, and it is helpful. So thank you for presumably, hopefully watching this. And hopefully I'll see you guys next week.